Alright, here we go. This is what I've been waiting for. Another proof. So we got our diagram here, and they want me to prove some statement that these triangles are similar using a two-column proof. On the regions, they're not going to say two-column proof. They're just going to say it, and it's just understood the way you prove things is with a two-column proof. Specifically, the left side are going to be the things you're saying, your statements. Okay? And then the right side is why. It's the reasons why you're making these statements. And you're going to keep track of it by labeling your first statement and the corresponding first reason that goes with it. And you're always going to start your proof with a given. And what they gave me in this diagram is the diagram. I'm going to say diagram with info. How did I know this diagram with all that information? It was given to me. And that's kind of like, you always want to start a proof with givens because that's going to be how you make the next couple statements. And when we're proving similarity, triangles are similar, we have three methods. We have the side-side-side similarity, which is three side facts showing that all the sides are in equal ratios. We have side-angle side, which is you're going to get two sides, and then the angle in between those two sides, they got to be congruent. And then the last one is angle, and that's just, can you match up two angles in here to two angles in there? Like, do you have reasons for saying that? If you do, that's the easiest method. Here, if we look at it, I'm going to guess it's not side-side-side because I don't know anything about that third side. And my gut's telling me it's probably not angle because, why do they tell me stuff about the sides? Why are they telling me this side is 5 and this side is 15? Why are they telling me this is 6 and this is 18? That looks like it's going to be side, angle, side. And you can kind of already see this angle in between, even though they don't tell us that those angles are congruent, even though they don't give it to us, I can make that statement. I can say angle B all the way to C, turn to A, angle BCA must be congruent to angle D to C, turn to E, angle DCE. And you have to put the angle symbol, because if you just throw out three letters, I don't know if you're talking about an angle or a triangle. They're two very different things, and you'll see that the last statement in our proof will look similar, but we'll have a triangle instead. I can say those angles are congruent because I know those angles are really vertical angles. And you can kind of see those are vertical angles. And remember, vertical angles, right? That whole entire little visual there, right? Vertical angles are always congruent. And that's the reason. That would be your reason for saying those things are congruent, because you're citing a theorem that, hey, vertical angles will always be congruent. We're going to keep track that I just said an angle fact. And we're going to start moving on now. We're going to make a ratio of sides. We're going to say side CE, this blue side from the big one. We're going to divide that by the corresponding side in the smaller triangle, side AC. And CE equals 18, and AC is 6. And when you do that, 18 divided by 6, turns out it's 3. And I know those sides correspond because A and C are the first and third, and E and C are the first and third. Right? E and C, A and C. I look at that similarity statement to find the matching stuff. So I've got my third statement, and my reason for doing that is, well, we just made a ratio of sides. We just compared corresponding sides. And why do, that's going to become evident in step 4 when we do the other ratio of sides. When we compare CD, right, something from the big compared to the corresponding piece from the small, BC, when we do 15 over 5, which is clearly 3, you can see that they're equal ratios. So when I write up my reason, the reason why I'm doing that is ratio of sides, because these 1, 2, 3 facts are going to prove what they asked me to prove. It's going to prove that triangle A, B, C is similar to triangle E, D, C. And all you need to write for your statement is which of these postulates, right, that's a U, postulates or theorems did you use? Was this the side, side, side? Did we use 3 sides? No, we didn't do that. Did we use 2 angles? No, we used 3 facts. We used the side angle side similarity theorem. And we can't call it the ASS postulate. We can't call it the AS postulate because I see that we wrote it up that way, but in the diagram, it doesn't go an angle, then a side, right? It doesn't go angle, side, side. Right? The SAS similarity postulate, it demands that your congruent angles, right? These angles, see how that A is sandwiched in between an S? Here's a side, here's the corresponding side, and another S. It's in between them. That's why not only does your diagram have to look this way, when you write it up, it's got to be written up as SAS, side angle side. Similarity. You got to be deliberate. If they're saying similarity, you say similarity. If we do congruence, it'll be congruence instead.